Hi, when I open an existing model in MATLAB new version 2025b, I got this type of errors. It shows the blocks are missing in this version. So why we are getting this type of error in Simulink models when we open an existing model in 2025b? When I deeply studied the issue, I find that it's because the Specialized Power System group is missing in Simscape electric toolbox. So what happened to SimPowerSystems group or Specialized Power System group in R2025b? Although I have installed Simscape electric toolbox, so what can be the possible issue? Is it relocated to another folder or what? Many users are confused in asking questions because the familiar SPS blocks like Powergui, Universal Bridge, and measurement blocks are no longer available in this version. This is because MathWorks has removed the Specialized Power System toolbox from R2025b. It's now owned and maintained by Opal RT Technologies, who obtained the rights from Hydrocubic. The new SPS version will soon be released separately by Opal RT, fully compatible with new MATLAB version. So I find this page very helpful as many people discussed this issue. This person commented that you can get the access from Opal RT by contacting them. So the Opal RT Technologies is changing the way the SimPower systems work. It shows that we take over the commercialization, support and future development of the technology of MathWorks under the name Specialized Power Systems. When I open the same model in another versions like R2024a, it's working correctly. And when I open it in 2023a, it's working correctly. So there is no issue in this model. In today's lecture, I will explain an important change in MATLAB 2025b. The Simscape Electric Specialized Power System library and its conversion assistant have been removed. If your models use Powergui, Universal Bridge or other SPS blocks, they won't open in 2025b. I will show you exactly why this happened, how to confirm it, and the practical ways to migrate your models, including which Simscape blocks and solver setup replace Powergui in the new workflow. If you found any issue related to this video, write your queries in the comments box below. Let's keep building your MATLAB foundation and solve the issues together. Don't forget to check out our next videos for more advanced techniques and share your thoughts in the comments below. And please don't forget to like, share and subscribe the channel. Let's start the lecture. There is a message showing above that this model uses Simscape Electric Specialized Power System block which have been removed in 2025b release. Use Simscape Electric blocks instead. For help updating your models, use the Conversion Assistant, SPS Conversion Assistant. So we will discuss what is this SPS Conversion Assistant as well. Historically, MATLAB released two different electrical modeling approaches, SimPowerSystems or Specialized Power Systems, a domain targeted at power engineers that used Powergui and Phasor discrete solver options and Simscape electrical physical networks. MathWorks has been converging users to Simscape physical modeling approaches for years. In newer versions, MathWorks removed the Specialized Power Systems library and the associated migration utilities. That's why models that rely on SPS blocks show warnings. So you will not find these blocks in newer version. So the solution is you must either convert them to Simscape electrical or keep running them in an earlier version as I open it in 2024A or 2023A. that still contains the SPS library. If we approach here in libraries, Simscape Electrical, here we will find the Specialized Power System group, which is missing in 2025b. Now let's jump into the solution. As the message shows that you can update the model automatically using SPS Conversion Assistant. If I open the command window and write SPS Conversion Assistant and press enter, it gives me an error that unable to find system or file single phase grid PVs model. So now I try which SPS Conversion Assistant. This assistant is available in 2025b version or not. It gives me the message that the file still exists in MATLAB. Now let's open the file for conversion, and it will give me an error. Is not a valid model name because it is not a valid MATLAB function name. This message actually means the function exists physically in the toolbox folder, but MATLAB is blocking its use. It's now an internal function. In other words, MATLAB has removed public access to the conversion assistant in R2025b, even though the file is still there for backward reference. Now let's try to see whether it's available in other MATLAB versions or not. Assistant, press enter, and it shows that unrecognized function or variable SPS conversion assistant. So it's not available in 2024a, and surely it will also be not available in 2023a. So I'm not sure why it's not working in 2025b. It should work in 2025b to automatically convert this model to physical model. So MATLAB actually wants a single physically consistent modeling approach that leverages Simscape solver, physical conserving boards, and modern infrastructure like units, hierarchical modeling, hardware-based simulation, improved sensor interfaces. So you can see MathWorks promoting Simscape Electric for power system modeling in their product pages and webinars as well. Let's solve this issue of Simulink modeling using simple examples. But first, I want to one of the older version 2024a and compare the results of an example in 2023a and 2025b. I open a blank Simulink file in 2023a. For simple electric circuit, we will need just a source and resistor, inductor, or a current source. So we can open these components using library browser or just click it here, DC voltage source. This is the fastest way to open it. We can find three DC voltage sources. So open the first one, the SPICE source, and now open the second one, the specialized power source. So you can find the difference between these two. So for now, just remove this one and open an inductor. For these two sources, you will find the mismatch between the color. It can be used for physical modeling, so I don't need this inductor. So what will I need? I will need an RLC branch, series RLC branch. I copy it, paste it here again, and move to here. I need only inductor, and here I only need a resistor and a current measurement source. So connect all these sources together, and I also use a display to display the current, or I can even use a voltmeter. So here I want just a small change to make it, for example, I want to make it 10, and I don't want any more changes it. And now I want to run it. So I'm facing some issues here. The diagram must contain a Powergui block. So without a Powergui block, it will not work. It can be in continuous or discrete depending on the situation. So I'm running it again, and now it perfectly runs and shows no error. So it is giving me the actual display of this circuit, or of this the current of this circuit. So this is an ideal circuit using specialized electric power sources. And now to make the same circuit using physical modeling, I will need a DC source, DC voltage source in SPS, right? Inductor, simple inductor, resistor, and current sensor. Instead of current measurement, I am using a current sensor, a display, and connect them together. And you will find it is not connecting together. Actually, the display block is an ideal circuit block, but this is the physical modeling or the physical blocks. To convert the physical block to ideal blocks, we need a PS Simulink converter. And now it connects accurately. You can see its color, the different color shows the conversion from physical modeling to a power system model or specialized power system model. So it works now accurately. Here I want just few changes, like I want to make it its voltage to 10 and save it. And I also want to remove this circuit from here. Now run it and see whether it will give me a message, a display message or not. So it gives me an error. It shows that each physical network must be connected to exactly one solver configuration block. So what is a solver configuration block? Solver configuration. And the block should be connected to this physical model system. It actually tells the Simscape engine how to solve that network. It is the Simscape equivalent of providing solver context for physical network, and it must be present for simulation. In older versions, every model had a Powergui block that handled the simulation algorithm for electrical networks. Either it can be in discrete or continuous, and define the solver method and manage initialization like FFT analysis or steady state analysis. In the new Simscape electrical environment, starting from 2025b onwards, all physical models are based on the Simscape physical modeling engine, not the old power system solver. That means you now need a solver configuration block to tell Simscape how to solve the physical network equations. For every physical Simscape network, we will need exactly one solver configuration block that connects to all parts of the power system through a common reference point. Without it, MATLAB doesn't know which solver to use, either local or global, how to handle differential algebraic equations, and how to initialize the physical states. In the parameters, we can find that there is an option start simulation from steady state, so we can check it, and there is a local solver. If unchecked, it uses the global solver set in simulation settings. It uses a dedicated local solver. It can be faster for complicated networks or for large networks. And the tolerance etc. are same, just like we are using in Powergui settings for continuous or discrete. So for this network, I am not using a local solver as it is a small network. So move to its properties. In the solver setting, we can start the simulation time and stop the simulation time. It's same as we are dealing it in Powergui networks. Variable step, fixed step, we can find any solver, or we can change the maximum step size, minimum step size, These are same as we are dealing in common Simulink models. Now I want to run it, whether it will correctly run it or not. So this shows the error. An error occurred while running the simulation. Steady state solve failed to converge. I don't want to run it in steady state and run it again. So again it causes an error. An error occurred while running the simulation. Its initialization is failed to converge. Here I want to use electrical reference and connect it here. It behaves a normal ground. We are using a ground in normal circuits. Run it. It now runs accurately and give us the result. So this is the way we can make a physical model. So we can also make it in 2025b as well. So let's start a new Simulink model and we cannot prepare an ideal network. For example, I am using the same components. Here you will not find an ideal specialized library items. So we are using inductor, a resistor, current sensor, a display, PS converter, and solver configuration block, and connect all these components together. And yes, electrical resist reference. Instead of ground, we will use electrical reference here. Similarly, we cannot connect it directly, and we will use it here at the PS Simulink converter. And now I want to change its voltage to 10. Sorry, its voltage to 10, and convert it anywhere in the physical model. Run the model, and we will find the same solution. So in this way, we can prepare a physical model. Moving to this model, so first of all, we will not use this Powergui block. We will remove this one. And I will show you just a few easy steps. Like here, I have used, for example, if I have used a current measurement block. So instead of current measurement block, I will need a current sensor here. I can use current sensor here. And instead of voltage measurement, I will use voltage sensor block. And instead of SPS series RLC branch, it's the inductor. So I will need inductor, simple inductor block, and I will connect it here. And instead of SPS diode, I think it can be available here. Yeah, I can connect a diode here. And instead of IGBT, we can use IGBT. It's for ideal switching, or we can use N-channel IGBT, depending on our solution which one we need it here. And make the relevant changes in the parameters. So in this way we can manually change the model or modify the model. But if you need to automatically convert the model, we will need this SPS conversion assistant, which is not available in this trial version, or maybe it can be, I think it's not available in the paid version as well. But remember that for each physical network, we will need a single solver configuration block. And for conversion from ideal network to physical network, we will now need a PS converter, Simulink converter, or Simulink PS converter. So PS Simulink converter will convert from physical network to simple Simulink network. And another one is from Simulink to PS converter. So Simulink PS converter will convert from simple Simulink model to PS model or physical model. So the conversion should be connected between these two models, or otherwise it will not be connected accurately. For example, I want to remove it here and connect this line here, this line here. It connected accurately, but if I connect it, it will not connect. Only if I convert from this one, I will use the PS to Simulink converter, because this is a simple Simulink block. I will use it here and then I connect it here. So it's accurately connected, and the line will also show the difference between the physical model and the Simulink model, the Simulink network. And if you need to change the color of like in this model, for example, I want to show you here. In this model, it shows the different color like the blue one. If you want to remove the color and make it black, just move to information overlays, and in this list move to Simscape domains, click on it, and you will find that its color is changed now. But this color is important, it should be connected, it should be different. To understand the features of both these models, in old version or in specialized power system, we are using either continuous or discrete for simulation mode. But in Simscape electric or Neve solver configuration, it can be handled by Simscape solver. In SPS, we are using FFT tool to analyze FFT, but in Simscape electric, we will use power spectrum or spectrum analyzer. The load flow analysis and steady state can be analyzed and built using Powergui in SPS. But in Simscape electric physical modeling, the initial condition of the blocks can be used for steady state analysis or load flow analysis. So we can change these initial targets. In SPS, we are using ground, but in physical modeling, we will use electrical reference. Please don't mix SPS and Simscape blocks. They are incompatible. SPS blocks need Powergui, Simscape blocks need solver configuration. And also understand the use of Simulink PS converter and PS Simulink converter. As this one is taking a physical signal from Simscape back into Simulink, while the Simulink PS converter is sending a control signal from Simulink into a physical system. That was the detailed overview of the latest release of 2025 of MATLAB version. If you found any issue, don't forget to check out our next video for more advanced techniques and share your thoughts in the comments below. Thank you.
Thank you for watching the full video. Don't forget to subscribe to the channel and ask your queries in the comments below.